Hello, grade 10s, and welcome to our next lesson on weather. And today we're going to be taking a look at how wind forms. We've looked at the parts of the earth and how the sun's energy heats the earth. And what I want to do now is look at how that starts to interact to form wind, because wind is obviously a really big deal when it comes to weather. So, as we previously discussed, you can follow along in your note packages as we talk about this, but convection currents, energy from the sun, will heat the earth, but it doesn't heat us evenly. In some places, the sun's light will strike more directly, for example, at the equator, and we get a lesser amount of heat energy happening at the poles. And we know that air tends to move. There's a continual movement of air as warm air from the tropics by the equator flows up towards the poles, it rises, and then it falls down, cold air sinks. So always remember that warm air rises and cold air sinks. So this is part of wind forming because we're going to have air moving because of the unequal heating of the earth. It's in part due because of the angle of the earth to the sun. Also, the earth is rotating at the same time, so there's a constant rotation or spin of the earth. Now, as that happens, we know that the spin isn't at the same speed everywhere else. If, for example, I was standing right around here and watching the earth spin, a person standing on the planet would have to travel a much longer distance than a person standing up on the top of the planet would have to travel in the same amount of time. So there's a difference in speed that's going on there. And regardless of whether you're at the equator or at the poles, we're going to have one rotation every 24 hours. But at the equator, in that 24 hours, you'll have moved 40,000 kilometers, whereas at the poles, you might have only moved 16,000. And that causes the Earth's winds, as they rise from the equator and fall towards the poles, to be bent. We have a bending of their direction. So now the air is not just rising and falling, but it's starting to bend, and we've got the beginning of wind. Now, this bending pattern is called the Coriolis Effect. In the northern hemisphere, any time that we throw anything and it leaves the Earth's surface, it doesn't actually travel in a straight line for very long because the Earth continues to move underneath us. Anything tends to move to the right of its intended direction. So this is a big deal, for example, if you're in a plane and you were trying to fly from the North Pole down towards the South Pole, down towards the equator, you would end up bending to the right and you would end up somewhat west of where you intended to go. Now, this is kind of a hard thing for us to picture, but I've got a YouTube video that I'll get you guys to watch. The link is above us here, and it will really help to clarify the whole situation for you. You could almost picture it at the same time if you were riding on the back of a truck and the truck was traveling pretty fast and you tried to throw a ball straight across the truck to somebody sitting across from you, that because the truck had moved underneath your throw, that they'd never catch the ball. It would always end up behind them. So this is kind of a result of our object in motion want to stay in motion, doing exactly what they're doing law. And it's called the Coriolis Effect. People used to think it was a force, and it's not really a force as much as it is an optical illusion. It's also the same thing that causes water to appear to swirl as it goes down your drain. So this is another factor that's starting to affect wind. Now, not just the hot and the cold air rising and sinking and then bending because of the Coriolis Effect, but we also have air pressure starting to be a factor here. Warm air tends to rise. We know warm air rises. And as it rises and spreads apart as it gets higher up, that creates a less dense area. That creates an area of low pressure. Cold air tends to sink. And as it sinks, it pushes particles together towards the Earth's surface, and that causes an area of high pressure. Air always rushes from areas of high pressure to areas of low pressure. That's going to happen all the time. So we know that the air itself, if I took a 1 square inch, if I drew a little draw on my paper and I drew it 1 inch by 1 inch and made a square, and I trapped all the air in that column from the ocean up to space, that square inch would weigh 14.7 pounds. So that's standard air pressure, 14.7 pounds per square inch. And that's how they describe it in the States. In Canada, in metric, we describe that as 1 atmosphere of pressure. So because we have this pressure, and it will go up or down depending on whether or not we are warm or cold, we have unequal heating happening around us, and we know air is moving from high to low, and that is the beginning of more wind patterns starting to happen. Now, interesting thing with these high and low pressures. If we consider storms, as warm air rises, the descending cold air has to move in to replace it, and air flows from high pressure to low pressure. Storms, and particularly tornadoes and hurricanes, will tend to form around the centers of lows. I always say low means snow, so think of stormy weather, rainy weather, hurricanes, tornadoes are always lows. And then, because of the Coriolis effect, these winds are directed to the right in a counterclockwise rotation. So around a low, the Earth in the northern hemisphere, the winds will always spin counterclockwise. And tornadoes and hurricanes in the northern hemisphere, if you take a look at them, we'll always be able to see them spinning in a counterclockwise rotation. In the southern hemisphere, this is reversed, and we will see an apparent clockwise rotation. So our low pressure systems are what causes our stormy weather. Low pressure systems spin counterclockwise. High pressure systems are associated with clear weather. Clear sunny days usually mean that there's a high pressure system sitting over us. So if you go over to a weather channel like the Weather Network and you look on the map for the H's and the L's, the highs and the lows, what you will notice is that anywhere it's sunny and clear, you will see a high pressure system. And anywhere where it's kind of rainy or miserable or snowy, depending on the season, you will see an L for a low pressure system. Now, we know that these storms don't just sit where they are. They tend to move. And living here in Brandon, we quite often go, well, if I want to know what the weather's going to be like here today, I'm going to look to see what Regina had yesterday. This is because of something called prevailing winds. Prevailing winds are the winds that blow most frequently from a particular direction. The direction that the wind is measured from is the direction how we name it. We live approximately here, where the X is on your screen. You'll see that our winds tend to come from the west. We call these the westerlies, so our weather tends to come from the west in Canada. Somewhat to the south of us, as we get down towards Florida, the winds blow traditionally from the east. They're called the northeast trade winds because these are the winds that first blew Christopher Columbus across the ocean when he discovered America. So we can see that at different points on the Earth's surface, as hot air rises and cold air sinks, and because the different speed of spin around the different amounts of circumference on the planet, the prevailing winds blow in different directions. From the east up at the North Pole, the polar easterlies. From the west at our elevation, which we call the westerlies, and from the east again. And those are our northeast trade winds, east, west, east. So it's the same in the southern hemisphere, and you have several pages in your notes showing that as well. Now it's interesting because of these east and west rotations, we actually end up with an interesting thing called the jet stream. The jet stream is like a fast flowing current of air. It's like a river in the atmosphere. The jet stream isn't very wide. It could be between 10 and 15 kilometers wide, or even a few meters wide. But it is often very fast. Sometimes the speed in the jet stream can go up to 300 kilometers per hour. And it always blows from the west to the east. And it blows in between these different areas of temperature difference. On a weather map, if you can find the jet stream, any location north of the jet stream is going to be colder weather, and any location south of the jet stream is going to have warmer weather, because air tends to rush towards the fast-moving current of air as it travels across the continent. One last thing I want to talk about quickly with you guys is what is El Nino and La Nina. El Nino is Spanish for the boy. And El Nino is a warming in the Pacific Ocean. So there'll be an area in the Pacific Ocean, typically just off the west coast here of California, near the equator, slightly south of California. And that warming tends to cause interesting pockets of strange weather all over the planet. In Canada, El Nino tends to make our winters mild and drier. Okay, the exceptions are the Atlantic provinces and Nunavut, where we'll still be milder, but it will be snowier. So El Nino winters are typically pretty nice ones. La Nina happens when the ocean in this part of the Pacific cools. La Ninas quite often follow El Ninos. La Nina means the girl. Now, La Nina winters tend to be pretty wet where we live and quite often colder. Okay? In the eastern half of our country, Ontario, Quebec, and the Atlantics, they'll be drier, but also somewhat colder. So there are these two interesting little weather phenomena that are influenced also by the warming and cooling of the planet and cause interesting weather patterns to form. I'm going to get you guys to watch a couple of other YouTube videos that I'm going to link in the description underneath this one. And then I'm going to get you to work on task 3. I have a few things I'd like you to watch because it's really hard for me to explain anything without being in front of you to show you. And so yay for other YouTubers who can publish much more interesting videos than what I have the capability of here. I'll give you a couple of days to watch that and to complete task 3 on winds and the weather.